Hello, in this video I want to discuss the Moyers Theorem. Now this is a powerful theorem for multiplying or taking integer powers of complex numbers in polar form. So let's say we have two complex numbers z and w and we express them in polar form. So we have z is r cos theta plus I sin theta and w is s cos phi plus I sin phi. Now our theorem for multiplying complex numbers in polar form tells us that z times w will be rs cos theta plus phi plus I sin theta plus phi. So if you apply this in a particular case where w is z, then what do we get? Well, we get z squared, which is z times z, is r times r, so r squared cos theta plus theta, so cos 2 theta plus I sin 2 theta I. Z cubed would be z squared times z. So we again apply the theorem and we get r squared times r, so r cubed, and we get cos 3 theta plus sin 3 theta I. And so we can carry on. And in general, what do we have? In general, we have the Moyers Theorem. And what does this say? It says that if you have a complex number z in polar form, so r cos theta plus I sin theta, and z is a non-zero integer, then z to the n, so in other words z multiplied with itself n times, is r to the n cos n theta plus I sin n theta. So you should note that whereas in our preliminary discussion we considered integer powers of positive integer powers of z, the theorem also applies to negative integers. So for instance, if we take z to the minus 4, then it will be 1 over r to the 4, in other words r to the minus 4, cos minus 4 theta plus I sin minus 4 theta. Right. Now let's look at an example. So we are given a complex number z is 1 plus root 3i, and we want to write z to the 8th and z to the minus 6th in standard form. So in order to apply the Moyers theorem, we must first write z in polar form. So we must get our r, which is mod z, and in this case that's going to give us 2. And now we must get theta. So we must find our theta, and let's just take the principal argument. So our theta will be between minus pi and pi, so that cos theta is real part of z over the modulus, and sin theta is imaginary part of z over the modulus. Right, so both of these equations, remember, has two solutions, each of them. So cos theta is a half, with theta between minus pi and pi, tells us theta is either pi over 3 or theta is minus pi over 3. And sin theta equals root 3 over 2 tells us either theta is pi over 3 or theta is 2 pi over 3. Right. Now the value for theta that we need is the common one. Right. So here for cos theta is a half, we have the option theta is pi over 3 or theta is minus pi over 3, and for sin theta is root 3 over 2, we have the option theta is pi over 3 or theta is 2 pi over 3. Right. So we need the common one. So our theta is pi over 3. So in other words, in polar form, z is modulus 2 cos pi over 3 plus sin pi over 3i. Right. And now we can apply the Moyers theorem. So z to the 6 is going to be 2 to the 6, no, actually want to calculate z to the 8th. So z to the 8th is 2 to the 8th cos 8 pi over 3 plus sine 8 pi over 3I, and we want to write this in standard form, so it is 2 to the 8th, 256. Now all we have to note is that cos 8 pi over 3, so let's write this as so that's going to be 2 pi plus 2 pi over 3 plus sine 2 pi plus 2 pi over 3I. Right, and now remember, sine and cosine are periodic with period 2 pi, so this becomes cos 2 pi over 3 and sine 2 pi over 3I, and we know cos 2 pi over 3 is minus a half, and sine 2 pi over 3 is root 3 over 2. And so we get minus 128 plus 128 root 3I. Right, so that's z to the 8. Now z to the minus 6. Right, again, it's modulus to the minus 6, so 2 to the minus 6 cos of minus 6 pi over 3 plus sine minus 6 pi over 3I. So this is 1 over 64 cos of minus 2 pi plus sine minus 2 pi I. So cos of minus 2 pi is just 1, sine of minus 2 pi is 0, so we get 1 over 64. And there we go. Right.